Every company aims to sell the maximum number of units of its products. But how does a company decide how many units to manufacture? For example, how will a car manufacturing company know how many cars to produce? The number of cars to be produced is calculated using statistical methods. Records are maintained for the number of cars sold periodically. This recorded information is analyzed using statistical methods and necessary predictions are made. Therefore, statistics is an important subject of study and application. We define statistics as the science of the collection, classification, analysis, and interpretation of data in any field of inquiry. Let's study this subject in detail. Look at the sales figures given here. Such information or set of facts in numerical figures is called the data. Data forms the core of any statistical exercise. The data given in this case will help the company estimate future sales figures. The data collected by an investigator with a definite plan in mind is known as primary data. The data that is not originally collected but is obtained from published or unpublished sources is known as secondary data. After collecting or obtaining the data, it has to be presented in a meaningful form which is easily understood and gives the main features at a glance. Before we learn how to present the data, let us quickly understand a few terms related to it. Look at the sales figures we saw earlier. This is the original form in which the data was obtained. Any data obtained in the original form is called raw data. The same data, when arranged in an ascending or descending order of magnitude, is called an array. In the data, the difference between the highest value and the lowest value is called the range of the data. Now look at this data. These are the weekly sales figures for the same company. Observe that the number of cars sold is the same for several weeks. The number of times or how frequently a certain value occurs is called its frequency. For example, the number 47 occurs 12 times. Hence its frequency is 12. This means that there are 12 weeks during which 47 cars were sold in each week. Let's find the frequency of all the numbers in the given data. We will note the frequency of each number and prepare a table as shown here. In this type of table, individual values and their frequencies are presented. Such a table is called an ungrouped frequency distribution table or a frequency distribution table. This is because each value of the data is considered individually and the frequency of each value is noted. Later, we will learn how to group the values of the data and form a frequency distribution table. Now, let's look at the daily sales figures of the company for the month of January 2008. We will now present this data in an ungrouped frequency distribution table. These are the numbers appearing in the data. This is the ungrouped frequency distribution table giving the daily sales for the month of January 2008. We've just learned how to prepare a frequency distribution table of daily sales for 31 days. Now, suppose the daily sales were recorded for the first quarter of the year 2008. The number of days in the quarter was 91. But how can you count the frequency when the number of days is as large as 91? Let's find out. To present such a large amount of data, it is convenient to condense it into groups as shown here. This is because the data contains numbers from 0 to 9. Then for each number we make a tally mark against the group it belongs to. A tally mark is a small vertical line used to mark or represent an observation. For example, the number 5 belongs to the group 3 to 5, and the number 8 belongs to the group 6 to 8. Observe that this is also a frequency distribution table. In this table, we have formed groups to note the frequencies. The data presented in this form is called a grouped frequency distribution table. Now, let's learn a few terms related to the grouped frequency distribution table. While tabulating the frequencies for a large number of data, we first organize it into groups. Each of these groups is called a class interval. Thus, 0 to 2, 3 to 5, 6 to 8, and 9 to 11 are all class intervals. The class intervals are formed by observing the data and deciding on the size of a class interval. The size of a class interval is called class size or class width. It is the difference between the highest and the lowest value of a class interval. For example, here the class size is 5 minus 3, which is 2. Observe that the size of all class intervals is the same. In a class interval, the lowest value or the left-hand value is called the lower class limit, and the highest value or the right-hand value is called the upper class limit. For example, in the class interval 6 to 8, 6 is the lower class limit and 8 is the upper class limit. Now observe this frequency distribution table. Here, the upper limit of a class interval is the lower limit of its subsequent class interval. Such a frequency distribution is called a continuous frequency distribution table. There are two types of continuous distributions. The first one is called an inclusive type frequency distribution. In the inclusive type, the upper limit of a class interval is included in the interval. For example, the value 4 will be included in the class interval 2 to 4. It will not be included in the interval 4 to 6. The second type of continuous distribution is called the exclusive type frequency distribution. In the exclusive type, the upper limit of a class interval is not included in the class interval. For example, the value 6 is not included in the interval 4 to 6. It is included in the next interval, which is 6 to 8.